Hi Year 9, this is your guidance video for a two-part lesson that I'm planning for you in week 7 of distance learning. So in this section what we're going to be doing is covering all the material in 19.3, working with gases in the lab. So you may wish to look in your textbook for that. In some of your textbooks it should be roughly around about page 278. So you'll be watching the video that I will be linking on this second slide over here, and then activity task 1 is to read through section 19.3, working with gases in the lab. So that is this section over here. So what you need to do is you need to read very carefully. This is what you're going to be covering in the first of the 2 lessons. So it's going to take you half an hour for you to get through all of the videos and to answer the quick quiz at the end of the first lesson. So I need you to look through 19.3, working with gases in the lab. The first thing that you're going to learn is that there are some different techniques and apparatus, some new apparatus, perhaps, or apparatus that you are not so familiar with in the preparation of gases in the lab. So I've got 2 videos here. The one on the left-hand side shows you how you can use a piece of apparatus called the thistle funnel. A thistle is named after a Scottish flower. That's the shape of the actual funnel. What that's useful for is it's useful for adding a large volume of acid or whatever reactant you want to have. In this example, it's an acid. But to add that very, very slowly. So you have a nice, gradual, gentle, controlled addition of the acid. Now, the great thing about this is that it also allows the volume of the liquid that you put, so the dilute acid in this example, it will allow that to weigh down the flow of the liquid into your reaction vessel over here. So if you're producing a gas, the gas is actually forced out through an easier route, and usually what happens is you collect the gas into another vessel over here, or maybe you might collect it underwater or upwards. It depends really on the property of the gas. So the thistle funnel is very good because you can add a liquid into a reaction vessel, you can produce a gas, and you don't have to constantly worry about where that gas is going. And you can also control where that gas is flowing. It doesn't have to go and escape into the atmosphere or around, particularly if it's quite an irritating gas for you to handle. So the second video on the right hand side here shows you a dropping funnel. So couldn't really find a good video for a dropping funnel, but I wanted to show you something. So this is the best thing that I could find. It's just a video for that shows the dropping funnel in a procedure, quite a complicated procedure, so you don't have to worry too much about the chemistry that's happening in here. Just keep a sharp eye out for something that looks like a funnel that you are adding very concentrated acids. It gives you a nice way of controlling the addition, particularly if you've got a tap at the end and you don't want to add all of your concentrated acid at the same time, as you would do with a thistle funnel, because you want to control the reaction. Perhaps it's very exothermic and you don't want it to cause any harm to anyone. So those are the 2 videos. Have a look through those. So one day you'll be able to return back into a lab and prepare a gas. The technique is called displacing the gas from a solid or a solution, and these are the 2 apparatuses that I use, but there are many, many examples. So we've got 3 gases that you should be able to remember from your key stage 3, carbon dioxide, hydrogen and oxygen. The typical way of making those gases, well, what you could do is you could put calcium carbonate and marble chips into something like this, the thistle funnel. Apparatus that you have on the left hand side, add some dilute acid, and the chemical reaction that we have learned very recently as well when we were covering acids and carbonates, it's there, so the balanced chemical equation is there. I do like this balanced chemical equation because it has all of the states of matter: solid, aqueous, liquid and gas. You can also make hydrogen that way. You can add dilute acid and you can have solid pieces of zinc underneath here. So that was another acid metal reaction that we studied recently. And oxygen. Oxygen you can have, there's a video later on and it shows you the generation of oxygen. So that's manganese 4 oxide as a catalyst. This is how we generate it in school. And we add hydrogen peroxide and that oxygen just bubbles through and we can collect it as, through water because it does not dissolve too much in water for the quantities that we actually need. So the second slide talks to you about task 2. So what I'd like you to do is I'd like you to watch this lovely video from the Royal Society of Chemistry. So this video over here talks to you about a reaction called the ammonia fountain reaction. It's a very lovely reaction. The first part of the reaction video talks about how ammonia is synthesized. So watch that very carefully and look out for how the ammonia is tested using damp indicator paper and damp universal indicator paper. That's going to be quite important later on in the lesson. So you should see that the ammonia is produced by heating a compound with a base such as sodium hydroxide. Calcium hydroxide also works as well. They generate the ammonia and then they test the ammonia as well. I believe that the ammonia is dried during the process to remove water. So collecting the gases, this is what I'm going to base my first quick quiz on. Sometimes you will find that it's quite easy to collect a gas. If it's not too bothersome, you can collect it in a gas jar. If it's heavier than air, it will just sink. So it's assumed that you're actually producing your gas and it comes down here. So you can just fill up a gas jar, and once your gas jar is filled, you can just put a nice glass lid on it, seal it with Vaseline so it's easy to move and it has a bit of stickability. If you're making something like hydrogen chloride or sulfur dioxide, you'd want to do that in a fume cupboard. Carbon dioxide is pretty safe to be generating this outside a fume cupboard. If your gas is lighter than air, instead of upward displacement, which is what I've just described, and by the way it's called upward displacement because what you're doing is you're filling your gas jar, and as you fill your gas jar with your new gas, the air inside it flows upwards. That's why that method is called upward displacement. So instead of upward displacement, if your gas is lighter than air, you can use downward displacement. So your gas floats up, starts filling the top of the gas jar over here, which is the normal bottom if you just put it on a bench. And the air that's inside gets pushed out by this new gas that you're using to fill this upside down gas jar. So that would work with ammonia and also hydrogen as well. You'd probably want to take some level of precaution with hydrogen as it is explosive. Ammonia is a choking, kind of like pungent gas. You don't really want to stick around when ammonia is there as well. It's quite unpleasant. It's got a very recognizable smell. So with hydrogen, you'd probably want to have a shield, use protective equipment for that. And with ammonia, you'd probably want to use it in a fume cupboard. Now, there are some other alternative ways. You may need to look very closely at this picture over here because this is actually a trough, which is essentially a bowl, but in science we call it a trough. TROUGH, and that's filled with water, and the supply of gas has been supplied into and through the water. Now this is a gas jar and it has been pre-filled with water. You turn it upside down and you plunge it into the trough of water, into your glass trough, and as gas is produced, that gas then pushes or displaces the water out until you have filled your gas jar with your gas. And because these gases that are chosen for this technique are sparingly soluble, that means they don't dissolve too much in water. It's a nice way of collecting the gas. This is kind of like the preferred way of collecting hydrogen. It's nice and cool. No real risk to people collecting that. And of course, if you wanted to really measure quantitatively how much gas, perhaps it's with rates of reaction, which is what we're going to be moving on to fairly soon, we will be using a gas syringe, and you can use that for any gas. So you've got 4 different methods, and that's going to be checked in your first quick quiz. And the second, that should take you up to half an hour. Now, the second lesson begins in the second half hour, and you have 6 clips that you need to be able to describe and give tests for. So if you do this in two breaks, two sessions rather, and you have a break inside in between, you may want to remind yourself of the ammonia fountain test. That gives you a description and test details. Again, look out for the damp universal indicator paper. It turns blue. It would normally be green before, and I think that's where your textbook kind of falls a little bit short. You should be able to say that the universal indicator paper turns from green to blue. That's a better way of describing the technique. And the second gas you have to do is carbon dioxide. This is a nice video for you to watch and learn the properties, learn the test, and learn the results. Same thing with the ammonia that we had before. The third one that you have to learn the properties, learn the test, and learn the result is chlorine. So I've put another video there for you. So hydrogen is the fourth one. Learn the properties, learn the test, learn the results. Oxygen, again, another video. Learn the properties, learn the tests, learn the results. And the final one, sulfur dioxide, which has actually come in very recently in the Cambridge syllabus. I've put 2 videos for the extension students. I've also thrown another gas that you might want to learn about. So for the A-star students, that should stretch you. Learn about hydrogen sulfide, but hydrogen sulfide, treat the testing as if you are testing for sulfur dioxide. Decolorizes this purple potassium manganate solution. Also, learn about acidified potassium dichromate from orange to green. It's not in your specification. That one takes you a little bit further, but funnily enough, that was actually a test that should have been covered at Key Stage 3 in your Year 8. I know that because I've just taught that test 4 weeks ago to my Year 8s. So it's just a quick reminder of that extra information should you need it because you forgot about it. There's 2 videos, nice little treat for you with that last one, 2 videos there. So once you've done that, you should be successful, and what I'd like you to then do is the final quiz on the gases. Thank you very much for watching. Best of luck with this one. I'm Dan Kareem, and stay at home, stay safe, and don't try any of these experiments, please, at home. Thank you very much. Bye for now.